Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. Last class we have seen how to evaluate the double integral where the limits for x and y is given. In this lecture, we are going to evaluate the double integral based on the region. So double integrals by region means without giving the limits for x and y, based on the region of integration, we have to identify the limits for x and y, then evaluate the double integral. Let us see that. So evaluate double integral over the region R y dx dy, where R is the region bounded by the two parabolas y square equal to 4x and x square equal to 4y. So R is the region that is given. How the region is given? It is bounded by two parabolas. So first let us identify the region, means we have to draw the curves, both the parabolas. So this is x axis, this is origin, this is y axis, and these two parabolas intersect at 2 points. Obviously one is origin, that we know. We have to find this point of intersection of these two parabolas, then only we can able to find the limits for x and y, right? So first curve is y square equal to 4x, equation 1. Second curve is x square equal to 4y, equation 2. So to find the point of intersection, let us solve these two parabolas. So from this equation 2, what is y value? X square by 4. That we substitute in equation 1. So y square means x power 4 by 16 equal to 4x. So this implies x power 4 equal to 64x. So x power 4 minus 64x equal to 0. So if you take x common, x cube minus 64 can be written as 4 cube equal to 0. So this is either x equal to 0 or we get x cube equal to 4 cube, means x equal to 4. So substitute in this. If x equal to 0, what is y value? 0. And if x equal to 4, substitute here, y equal to x square by 4. So we get y is also 4. So first thing is, this is obviously origin 0 comma 0. At x equal to 0, we got y value 0. And at x equal to 4, we get, so this is 4 comma 4. Now we have got the region. So this is a common region between these two parabolas. Whenever the limits are not given based on the region, we have to identify. So first let us take x limit as constant. Let us fix x limit and write y limits in terms of x, right? So how to fix limits means, see here, x coordinate changing from 0 to 4. So x varies from 0 to 4. Now we are fixing x limit as constant. Now from these two curves, equation 1 and 2, write down y in terms of x. So to write y limits in terms of x, we have to draw a vertical line or a vertical strip in the region. So let us draw one vertical line or a vertical strip here. Now imagine that you are standing here. This is your foot, this is lower limit, and this is your head touching another curve which is upper limit. So what is this curve and what is this curve? This curve is x square equal to 4y and this curve is y square equal to 4x, right? So we can see this upper limit touches the curve y square equal to 4x. So obviously another curve touches x square equal to 4y. So from these two equations, write down y in terms of x. So here upper limit will be y square equal to 4x. From this I want y value. So what is y here? 2 root x. What is lower limit? X square equal to 4y. So from this what is y value? X square by 4. Now we got both y limits and x limits. So this can be evaluated as y is equal to x square by 4 to 2 root x, and what are x limits? 0 to 4, and the function is y dx dy. So 80% of the problem is done. We have identified the region of integration in this graph and we have identified the limits for x and y. Whenever one variable is having constant limits and one variable is having vertical limits, variable limit, so first integrate with respect to y, then with respect to the constant limit, that is x. So this can be written as x is equal to 0 to 4, y is equal to x square by 4 to 2 root x. Function is, what is the function given? Y dx dy. Y, first integrate with respect to y, then with respect to x, isn't it? So this can be written as x is equal to 0 to 4, integration of y dy is y square by 2, and these limits are x square by 4 to 2 root x, then dx. So x is equal to 0 to 4, y limits are given as 2 root x and x square by 4. So substitute the upper limit, 2 root x whole square by 2 minus lower limit. So in place of y, write down x square by 4 whole square by 2 dx. So this can be written as x equal to 0 to 4. Here 4 root x whole square is x by 2 minus x square by 4 whole square means x power 4 by 16, by 2 means by 32. So dx. So this is 2 ones, 2 2's. So integration of x dx is x square by 2 minus x power 4 integration is x power 5 by 5 into 32. And what are the x limits? 0 to 4. So upper limit, in place of x, write down the upper limit 4, that is 4 square 16 by 2 minus 4 power 5 by 5 into 32. So this is 4 power 5 by 5 into 32. You can simplify this, right? Now let us see one more problem. Evaluate double integral over the region R xy dx dy, where this R is the region bounded by x-axis, comma, ordinate x equal to 2a, comma, and the curve x square equal to 4ay. So double integral over the region R. How R is given? Bounded by three lines. One line is x axis, another ordinate, another line is x equal to 2a, and this curve. So there are one curve and two lines. In between these, the region is given. Let us see. First, let us draw the graph. This is x axis, this is origin, and this is y axis. Bounded by x axis, this is one line which is given, x equal to 2a and x square equal to 4ay, right? This curve is given by x square equal to 4ay, and this line is given as x equal to 2a. So this is the region of integration we have to find. So this point is 2a comma 0, this is 0 comma 0, and this point is x is 2a. So x equal to 2a is one line and x square equal to 4ay is another one. So substitute this here. So 2a whole square is equal to 4ay. So 4a square equal to 4ay. So 4 cancel, 1a get cancel, y is equal to a. So here x is 2a, y equal to a. So we got the point of intersection of the line and the parabola. Region of identifying the region of integration is done, and identifying the limits for x and y is done. So first, this can be written as integral of xy dx dy. This can be written as, always remember, let us fix x limit constant. So we can see here x is changing from 0 to 2a. Now write down y limit as in constant in terms of x. To write down y limits, we have to draw a vertical line or a vertical strip in the region of integration. Say lower end of this line touches x axis, upper end of this curve, another end touches the curve, which is x square equal to 4ay. So what are the limits? Lower end touches x axis means y equal to 0. This is x equal to 0. Another end touches the curve. From this, I want y value, which is given by x square by 4a, right? And the function is xy dx dy. Now you don't bother about whether it is dx dy or dy dx. See limits for x and y. Y is in terms of x and x is constant. So let us integrate with respect to x last. Let us first integrate with respect to y. So y is equal to 0 to x square by 4a, xy dy, then dx. So x equal to 0 to 2a. What is integration of xy dy? X into y square by 2. And what are y limits? 0 to x square by 4a, then dx. So x equal to 0 to 2a, x into, in place of y substitute upper limit x square by 4a whole square, x square by 4a whole square total divided by 2 minus 0. So we can easily evaluate this. 0 to 2a, 1 by 2, write it outside, x into x square whole square is x power 4, x into x power 4 is x power 5 by 16 a square dx. So if you evaluate this, x power 5 integration x power 6 by 6, so 1 by 16 into 2, so 1 by 32 a square into x power 6 by 6, and substitute the limits for x, which is given as 0 to 2a. So if you simplify this, we get the region between this is given by, you get a power 4 by 3, right? So this is how we find the region of integration first, then evaluate the limits for x and y. Let us see one more problem. Evaluate double integral over the region R x square plus y square dx dy, where R is the region in the positive quadrant for which x plus y less than or equal to 1. So first let us draw the region. This is origin, this is x axis, this is y axis, this is A, say this is B, this is origin 0 comma 0, and this line is given as x plus y equal to 1. Now the region is x plus y less than or equal to 1, means for this line towards the origin. This is the region of integration. Positive quadrant means only in the first quadrant. That's why the region is not in this areas, right? Since we know the region is in positive quadrant, fix x limit as constant first. Always when the limits are not given, either you fix x limit constant, write down y in terms of x, or you fix y limit as constant, then write down x limit in terms of y. So let us fix x limit as constant and write y limit in terms of x. So to find the y limits in terms of x, what you have to do, take a vertical strip or a vertical line in the region of integration. This vertical strip touches the lower end x axis, that is, this is the upper limit, right? So we have to write down the limits. This is say 1 comma 0, I mean coordinates, this is 0 comma 1. We can clearly see that if you are moving from this point to this O to B, x varies from, clearly you can see on the graph, here x coordinate is 0 and here x coordinate is 1. So x varies from 0 to 1. Now we have fixed x limit as constant. Now write down y limit. Lower limit touches x axis, so y is equal to 0. Another end upper limit touches the line x plus y equal to 1. So y value is 1 minus x. So 0 to 1 minus x. So this can be written as x equal to 0 to 1, y is equal to 0 to 1 minus x, and the function is x square plus y square first integrate with respect to y first, then with respect to x. So this can be written as x equal to 0 to 1, x square into dy is y plus y square dy is y cube by 3. Limits are 0 to 1 minus x dx. So x equal to 0 to 1, x square into, in place of y substitute the upper limit, plus 1 minus x whole cube by 3 dx. So this is x square, x equal to 0 to 1, x square minus x cube plus 1 minus x whole cube by 3 dx. So if we evaluate this, x square integration is x cube by 3. So this is x cube by 3 minus x cube integration is x power 4 by 4. So this is x power 4 by 4 plus 1 minus x whole cube by 3 integration is 1 minus x whole power 4 by 4 into 3, 12. So we have, this is minus sign. Already plus is there. So 1 minus x whole cube is 1 minus x whole power 4 by 4 into 3, that is 12. So limits for x is 0 to 1. So upper limit, substitute x equal to 1, this is 1 by 3 minus 1 by 4. Substitute x equal to 1 means you get 0. This is upper limit minus lower limit. Substitute x equal to 0, so we get 0. So minus x equal to 0 means you get 1 by 12. So this is 1 by 3 minus 1 by 4. Minus of minus is plus 1 by 12. So if you take out the LCM as 12, 4 minus 3 plus 1. So 2 by 12, that is 1 upon 6. So this is how we evaluate the double integral. Next class, let us see few more problems on double integral without region and change of variables from Cartesian to polar coordinates. Right? Thank you.